Hi, welcome to trailer video number 22, Fusion Confusion. We're going to show that there's funny business going on with regard to the recent 2022 Fusion Breakthrough announcement. We're going to show you the hype, we're going to explain the reaction, and then we're going to show you the contradictions to what they are claiming. And then I'm going to show you historical examples which will significantly alter your view of science and what your expectations of science should be. Okay, after that, I'm going to show you misconceptions that'll be much more believable after you see this. And then I'm going to show you the EtherealMechanics solution for future power and why it's superior to anything they're working on over here. And then as an add-on bonus, I'm going to show you an update to the EtherealMechanics particle model and show you how EtherealMechanics shows that tritium decays into helium-3. That's just an add-on bonus because helium, the tritium decay is part of what this reaction is here, so it's pertinent to put that into this video. So if we look at what the major newspapers and news outlets are saying, this is The Guardian, and they're saying successful experiment could pave way for abundant, that's a key word, clean energy in the future, but major hurdles remain. Other news articles say major engineering hurdles remain, so that they clearly dump this in the lap of engineers to make it work. I'm not going to read this one to you, but here's the key takeaways if you read enough of the articles. They're going to say, this is the first time more energy was gotten out than was put in since effort began in the 1950s. There are a lot of technologies that began in the 1950s that have done exceptionally well, that have had explosive growth. Computers, DNA, helicopter flight, everything of those things were invented. We have tremendous things today, and all of those have pretty much become child's play today. Number two, if they say it's the pathway, it isn't bountiful clean energy, but it's the pathway. So we're not really there yet. And of course, whenever you do anything, you have to say fight climate change. That's like the buzzword you have to throw in for whatever reason. Okay, and number three, they always say major engineering hurdles remain before it can be put into operation. Again, they're dumping it in the lap of engineers. They're basically washing their hands and saying, oh, yeah, you got engineers, got to figure out how to make it work. We did our part. So let's look at the reaction that they got. They have this deuterium atom over here. They have a tritium atom over here. These are the mass and atomic mass units. And then they have a reaction which they add some laser energy into. And then the resulting components they get is a neutron and a helium atom. Okay, now the key here is if you add up the weight of the components of the output and subtract the weight of the components of the input, the difference is this much mass, and that would effectively be the output energy that they got. And as long as this energy is bigger than the energy they put in, then they can claim success. But the problem is they're only looking at this reaction. Okay, then there's many other considerations, and I mean, there's going to have to the toxic waste reclamation, not necessarily the output products, but you're going to have coolants, lubricants, dielectrics. You're going to need repair parts. You're going to need human worker, pay, benefit, retirement. All this is going to have to be paid from the excess energy that comes out the other end. And are they considering the magnetic containment field energy requirements? I don't know. I don't think so. I think they're focusing only on the reaction at the cell and the seed. And that's the other thing is you're going to need a mechanism to feed new fuel into the reaction and a mechanism to carry off waste products. Okay, even if the waste products are not dirty, but let's say they're just the helium, whatever. Well, you need to get the helium out of the way so it doesn't interfere with the next reaction. Okay, if you have anything in there that in the way of that reaction that's occurring, it could cause these things to become radioactive, and then you're going to have radioactive waste. Okay, there is so many things that need to be accounted for, and in the end, I do think these will all eat into the energy, making this a non-practical system. Okay, they've been doing this since the 1950s, and if all of a sudden now it became practical, I don't think so. Okay, and let's look at their claim about abundance. Okay, tritium is a short-lived waste radionuclide. This is in from ScienceDirect.com. Tritium is naturally produced in very small quantities in the atmosphere, comprising 10 to the minus 18th percent of natural hydrogen. Tritium, okay, and that the natural steady state global inventory of tritium is only about 7.3 kilograms. So how the heck is this abundant? Okay, even if you don't even take tritium, look at deuterium. It's only 0.02% of all naturally occurring hydrogen. So of the reaction output energy you get after you subtract the input energy, you're still going to have to take more energy to bleed that energy off to run a deuterium, tritium production facility so you can produce the fuel inputs, because they're not readily there. They're not abundant as they are claiming to be. That's why they're calling this a pathway to abundant energy. It is not. But let's cover, instead of the pages and pages of stuff that I was going to cover, let's just cover 3 of the major items here. The first item is that you need unstable matter, and that unstable matter is not abundant. Okay, and then I'm going to show you that we're viewing matter the wrong way. Okay, so it doesn't matter what reaction you're doing, whether you're doing a fusion reaction or a fission reaction. Both of these reactions require unstable matter. I'm showing the unstable matter as purple. Okay, for fusion, you need at least one component to be unstable. Okay, and then when you fuse those together, your output product is heavier. Okay, but there's a difference. It doesn't add up. That difference is made up by an excess of energy, and that's what we see with the fusion result. We have a little bit of mass doesn't match, and that is a resultant energy output. For fission, we take a very heavy molecule, let's say plutonium, and again, these numbers are just schematic in nature, and we cut it in half, and that's going to produce 2 smaller components where these numbers don't quite add up to the original, and that difference is made up by some excess energy output. Okay, in both cases, we have to use unstable matter. Unstable matter is rare. I've already shown you that. And people say, well, we use plutonium and it's pretty effective and we have fusion and fission power, blah, blah. Yeah, well, that's because the plutonium, the uranium, is in very small areas of the world. And it's concentrated in very small areas, and it can be concentrated in a practical matter. And the other good thing is with at least fission power is that you can create more fissionables by keeping it close to the reaction. So, all right, so if we're going to produce, maybe we can produce the fissionables for fusion using a fission reactor. But again, we're playing with dirty fission again. Okay, and unstable matter, whether it's for fusion or fission, is problematic. You could have catastrophic failures, loss of control, meltdowns. Both of them can be weaponized. The fuel is rare. And when all costs, risks, and long-term impacts are accounted for, will it really be worth it? And of course, you're going to have radiation. Okay, and what I'm going to talk about now is that we are wrong. We are looking at things the wrong way. And before I explain a more correct way to look at things, I'm going to show you a historical example that will profoundly alter your view of science and what you should expect. The name of the movie is The Race for the Double Helix. This is from IMDb. Actually, it looks like it's really an episode of some kind of historical anthology, but the length of the video is 1 hour and 37 minutes, and it was first aired in 1987. It's actually written, it looks like Watson and Crick are the people who discovered the DNA, and it looks like it's actually partly written. The screenplay is written by James Watson. I think that's the same Watson, based on the book The Race for the Double Helix. Okay, this video can be seen online for free at these 2 links. I'll put these links at the low bar. Comes in 2 parts. Each part's about 52 or 53 minutes long. But I can show you the entire video. Okay, this is part 1, part 2. The blue areas where they're frustrated that nothing ever works. They're just, it's just a whole bunch of nerds gone crazy trying to figure out why it doesn't work. Hand-wringing. Okay, then at 37 minutes and 41 seconds, so the whole movie can be reduced to this little spot here that's 2 minutes. Okay, where they're still at the point where it doesn't fit together. Somebody overhears them, shows them they're using the wrong model, and then all of a sudden it all becomes child's play. And then the last 13 minutes of the movie, they're patting each other on the back for how smart they are and ogling the DNA molecule. So the entire movie can be summed up in this 2 minutes. You actually don't need any other part of this video. That's the whole, nothing's different before here and nothing's different after here. That's the entire essence of the movie is 2.5 minutes. And let me show you those 2.5 minutes in a little bit more detail. So at 37 minutes and 41 seconds, that's into the second half. Okay, Watson is saying to Crick, and he's talking about DNA, This is either a monster of complexity or it's so simple we are missing it. Okay, and what you see in the background behind them is they have made up a metal structure to take the DNA molecule, and all they have is this metallic frame here. I believe the outside molecules are known, but the molecules that go in between to form the ladder, those are the parts they're still trying to fit together. Okay, at 38 minutes and 15 seconds, and here's that model in the background that this other guy just wandered in to take a look at. He's not part of their team. He's just some bystander that just happened to wander in to look at it. Okay, and then Watson says to Crick, "This is driving me crazy. There's got to be a way these things fit together, but there isn't." And then this guy overhears that, and so he comes forward, and he looks over their shoulder. His name is Jerry, and Jerry says, "Did you get these molecular forms from textbooks?" Watson says, "Yeah, all of them." And Jerry says, "Well, let me tell you, they're all wrong." Go figure. Things printed in textbooks that are all wrong. And the next statement he makes is very, very, very poignant. The next phrase that Jerry says is, "Take it from me. It's one of those guesses that have been repeated so often, it's got the status of fact." In other words, somebody made a guess about something. Everybody just dives on, they repeat it in textbook, and after a while, everybody thinks it's an irrefutable fact, and nobody bothers to go check it. I've seen that often and often and often in textbooks. Okay, and then there's a saying from a scientist in a Discovery Channel episode, which I've never been able to find again, where I heard this. I wasn't watching, I was listening while I was doing something else, and I heard this phrase from the scientist. "The greatest obstacle to science is the illusion that we think we know what we're doing." Okay, when I looked over to see who the science was so I can give the proper accreditation here, the episode had passed and I couldn't get the guy's name. It was something like Dr. David Disney or something like that, and I haven't seen the episode since. So if anybody has seen this episode so I can give the proper accreditation here to that guy, please let me know. Okay, and then at 38 minutes, a mere 6 seconds later, okay, Jerry corrects their arguments and crosses out what's wrong and puts in what is correct. And then Jerry says, "Go ahead, try that." And then Watson's face is like, bam, his eyes blow up. His expression's like, wow, that's it. It works. And then a mere 3 seconds later, out comes the very dull scissors they give you in kindergarten so you don't hurt yourself. And Watson's cutting out pieces of construction paper with child's scissor. And it's so easy, it's child's play. He's putting these pieces together. It's obvious. Okay, and that is a critical point of this. When the science is properly understood, it's child's play. It's obvious. If we're having problems, it's because we don't know what we're doing. I mean, look at this entire movie. We don't know what we're doing. We don't know what we're doing. We don't know what we're doing for essentially an hour and a half. Wasted time. Don't even need to watch that. And then all of a sudden, when somebody gives them the correct model, it becomes child's play, and the rest of the movie is us patting ourselves on the back for being so freaking smart. Okay? If we had known the correct models in the beginning, this would have been a 10-minute movie at max, and it would have been ho-hum. Okay, and see what other things in science are we've been stagnating on for decades and decades and decades, getting absolutely nowhere because we have the wrong models. This is a very common theme in science. Okay, ultimately, if we know what we're doing, science should be child's play. If we've not been able to reconcile relativity and quantum mechanics in over 100 years, then we need to step back and consider that something is wrong, has to be wrong. Okay, and this is actually the basis for my 23rd rule of acquisition called the stagnation tell. I'm going to actually make a separate video on this rule of acquisition, and it's going to contain pretty much most of what you've seen in this little segment here. Okay, so what we got from that video, that if we know what we're doing, it should be child's play. And that's an expression used in the West that means a trivial task. Okay, and what EtherealMechanics tells us is that atoms are not sources of energy. They're the engines of nature. They're the engines of nature. And if we look at them, the electrons kind of look like pistons of that engine. And if we compare that and use an analogy of a car, this is matter. This is the engine of nature. And the fuel is really back where the fuel tank is. But in order for us to use the fuel, we're going to need an engine to burn the fuel. Okay, and the problem with physicists are, instead of using the engine to burn the fuel, they're trying to smash the engine apart. Oh, sure, if you smash the engine apart exactly when the pistons fire, you're going to get some energy out of the engine that you can maybe boil some oil with and run a turbine with. But that's not the most efficient way to use the engine. That's wasteful. That's idiotic. Okay, like any good engine, we're going to load the engine. We're going to attach another accessory to the engine that will help us develop power directly from the atom. None of this converting it into heat and then driving a steam turbine. All of those have losses as well. Okay, we want to load the engine down directly, and this is an example of what I'm talking about. We're going to load the engine down directly and generate power directly from the engine. No steam and steam turbine middlemen. Those are also a waste of energy that are not accounted for, that I should have added in the list before, but I totally forgot about it. That is important. Now, again, this is just schematic. We're not going to actually touch a turbine or a generator directly to an atom, but it's going to be something similar where we're going to develop energy directly from the atom by loading it down in a specific way. And I've recently come to the conclusion of exactly how that can be done. Okay, but I'm not going to release that right now. But basically, these little generators, these atomic generators, are going to be tiny. Tiny, tiny, tiny. And this is a picture of a MOSFET transistor where these MOSFET transistors are very, very, very tiny. But by putting thousands of them together, working in parallel, all working the same way, we can control power of hundreds of amps and thousands of watts with these little tiny devices that could be damaged by something simple like an electrostatic shock individually. But together, they can do massive amounts of work. And then we're going to take that fabric of these tiny little atomic generators and we're going to put them into a standard cell package. And this isn't going to be the Energizer, it's going to be the Ethergizer. And it's going to last a heck of a long time. It won't last forever. That's what the minus means. It's forever minus. It's just not quite forever. The reason why is because when you load down an engine, it may not last. The engines wear out. So I don't expect, and then there's other things like corrosion and other extraneous things that will eventually cause these batteries to fail, but they should last at least a generation or two. Okay, now, and since we'll be using normal matter for these, it'll be abundant, it'll be clean, there should be no waste products as far as I know, there should be no radiation, and because these are normal matter, it cannot be weaponized. And because this will be a small device that you can own, it'll be decentralized. Nobody can shut off your power because they don't like you. Unless they steal it from you, of course. And because stable matter is being used, it should be last for generations. Well, unfortunately, this is not a very good business model, but one thing I've learned in life is these business models where they put planned obsolescence in are crap. If you can sell somebody a good product, that will make everybody happier, and that's what makes money more valuable. These business models where people steal from other people using these shim-sham things, that makes money less valuable. So I can go on a whole thing about that. Anyway. Now, you're going to say, wow, this sounds super fantastic. Impossible, you say. Well, considering that in 1959, the very first transistorized computer filled the entire building that you see here. And it could do 200,000 additions per second and 25,000 multiplications per second. And it had probably less than a megabyte of RAM or something. I don't know how much RAM was in it, but it was in the megabytes. Okay, considering where we've come now, is that device that can fit in a child's hand, that a child can use, has more computing power than existed on the entire earth in 1959. And it fits in his hand. It runs on batteries. We have taken this technology that began in the 50s, just like fusion power started in the 50s, and we've turned it into child's play in only a couple of generations. If you went back to these engineers back there and told them this would account, they would laugh at you. They would say, no way in heck can you fit all this computer equipment into something somebody can hold in their hand, let alone be simple enough for a child to use. I guarantee you they would look at you like you're crazy. And then you look at how long it took us to cross the ocean back in the days of Columbus, months. And if you went back to these sailors and said, oh yeah, we're going to not only take all your passengers on your ship, but all your cargo, and we're going to be able to move it across the ocean in a couple of hours, they would laugh at you like a lunatic. They'd probably burn you at the stake for being a witch or a heretic. Okay? And also, we have turned this into child's play away. Also, flight technology has been reduced to child's play. Okay, now we're going to talk about an EtherealMechanics update to the Pretonic Standard model. The link for this will be in the low bar, so you can watch this video if you want, which gives you the foundation. If you recall from that video, we showed that the up quark is 2 positive pretons that are 1/3 charge each. The electron is 2 negative pretons, which are 1/2 charge each. A down quark is made of the components of an up and an electron. A proton is made of 2 up quarks and 1 down quark. Okay, that's 6 positive pretons, which we show as a pentagon. A hexagon. And the electron is internal to this structure. And we call this internal electron, we call that the centron. Okay, a neutron is made of 2 down quarks and 1 up quark, which is essentially 3 up quarks and 2 electrons. Okay, and that's how this structure is. In this case, the electrons are outside. They're not at the orbit of an electron, which would be in a hydrogen atom. These are very, very close to the positive preton structure, the hexagon. Okay, and if we look at tritium, a tritium is a proton and 2 neutrons. But let's get rid of all this fancy packaging. These stars here are fields for putting other parameters when I finally figure out how to make this, this fancy dancy representation. But let's get rid of all the fancy dancy packaging and just show you the pretonic structures. So in tritium, you have this proton with its centron, and then you have 2 neutrons that are attaching to it. Now, I don't know if this angle is going to be correct here, and I don't know if the distances are to scale. I don't know, but this is essentially what's going on. This is schematic in nature. And these 2 outer electrons want to get at this positive proton. They're highly influenced by the positive proton. Okay, and what's going to happen is these electrons are going to shift 1 position up toward the proton, both of them, and they're going to cause this centron to be popped out like a zit. Okay, and then this proton is going to become a neutron, and these neutrons are going to become a proton, and this is how it looks. And then that electron is going to be popped out as a free electron, and this is going to shrink to become a neutron, and these guys are going to expand to become a proton. Shrinking means it increased in mass. In EtherealMechanics, when things get closer together, the mass, or what we call the inertia, increases. And this guy is now going to become a neutron. I should have shown these outer electrons closer to this, but you get the idea. And if you want to see how it's represented with their particle models, you have the tritium, which is a proton and 2 electrons. It belches out an electron, and then you end up with a particle that's 2 protons and a neutron. Okay, if you ask them where does the electron come from, they will not be able to tell you. Oh, and we also get some energy out, which is represented here by their neutrino. Okay, so this neutrino, this could be created from what we're going to call collateral scatter. There could be other photons around here. This is energy excites, and that could form a neutrino. Okay, but we'll get into photons later. And these structures are consistent with the Pretonic models. Okay, so as a final note, I am no longer going to comment on mainstream physics. First of all, I don't have the time. I have too much I have to do with EtherealMechanics, getting to, now that I have an inroad of where I can get to the ether geyser concept. Okay, and also, the physicists have gone off the rails since they gave the Nobel Prize to quantum entanglement. I'm like, holy crap. The Nobel Prize has basically become the Hugo Award for the fiction that physicists produce. Okay, because if the quantum entanglement cannot be used for faster-than-light communication system because it produces random and useless results. Well, how did they verify the effect to begin with? Okay, people should be asking that question. And people say, well, it's obvious it was the Bell inequality experiment. I'm sorry. I've run a simulation. There's a link going to be in the low bar for trailer number 11, where I've run the Bell inequality experiment using computer simulation. I get the same results they do using normal physics. Same results using normal physics. There's no way if this thing produces random results, then you can prove that it's even there to begin with. Okay? So, and on the other thing that they're going off the rails is with a new thing called time crystals, where they're applying energy to crystals and they're oscillating in a periodic fashion. And they're saying, well, that means the crystals are periodic in time. Well, duh. If space and time are related, then if you have a structure that's periodic in space, and obviously you're going to get a periodic signal from it. And so they've done nothing but basically reinvent, the ruby laser works on that principle, which has been around. Then you have quartz crystals, which we use all the time for watches, and the electronic experiments will be running. That I'm working on the new crystal model. Big deal. Okay, they think they've invented something new. They're causing a crystal to oscillate again, and they think they've invented something new. Really? Okay, so you can see, the other reason I'm not going to comment on this is because it gets my blood boiling. The frustration that I can't do my job because they're dorking around with stuff that doesn't freaking work and it doesn't matter. Okay, so I'm going to spend my focus on getting new Electromagnetic V5 published and produced. Okay, while I'm going to be exploring the little opening of the rabbit hole that I figured out for getting to this goal here, because this would be a very interesting goal to get to. Okay, so if you're interested in being support and you understand what I'm telling you, that they're going nowhere. They have become science fiction writers. Okay, you look at anybody like Mikio Kaku, Brian Greene, all they do is produce book after book after book, just like the Nostradamus guys produce book after book after book with the same predictions, and nothing ever happens. They become science fiction writers. Okay, I'm an engineer. I can't do work. I can't do work on science fiction. I need real technology to build the fantastic machines that are going to save the human race. And if you want to see the real threat to the human race, go to my website, Distinti.com, click on 500C or Die. There's a couple of videos in there that are very compelling, that there's something bigger than climate change that's facing us. It's sustainability. And in fact, that we're all on the same boat. All of our eggs are in the same basket. But we'll get that on your own. And then if you want to support this work, there's the Patreon site. We have a blog site. You can go there. And everything's there. And this is the EtherealMechanics Patreon site. Yada yada yada. This is the new EtherealMechanics site where I'm putting only EtherealMechanics stuff. And then we're doubling it on Odyssey and BitChute. I have to update these. These are behind this right now. I got to update this. This is the blog site. Thanks for Sebastian for taking care of this. Again, these are just a repeat of the links. So thank you very much. No more voodoo physics. And have a great holiday. Take care.